First of all, I want to express my appreciation to the organizing committee of this symposium, permitting me to show my research, to present my research. We're going to talk about the effects of nitrification inhibition and K-phosphonate on Hass avocado yield. When we talk about nitrification, it's an inherent process, oxidation process, mediated by bacteria, where ammonium is oxidized to nitrite, and part of this nitrite is a very labile component. Part of it is emitted to the atmosphere, and part of it is transformed to nitrate. Nitrite, when is emitted to atmosphere, is polluting the atmosphere. Also, nitrate, when it reaches the soil, where you have excess in the soil, it can leach to the groundwater, polluting also the groundwater. When we make an inhibition of the nitrification process, we get accumulation of ammonium in the soil. So without nitrification inhibitor, when we have nitrate in the soil, as I said before, nitrate can be leached to the ground soil. Now, the ammonium can be assimilated in the root cells. And because ammonium is charged positive, the cell becomes positive also. And the little hydrogen goes outside. So we have this acidification of the rhizosphere when we are doing nitrification inhibition. So now, here you can see a tree suffering of Phytophthora. Phytophthora is root rot, and is caused by a fungus called Phytophthora cinnamoni. Phytophthora phosphonate is globally used for the control of root rot caused by Phytophthora cinnamoni by causing an increase in the tree resistant to this disease. Phosphonate is not so much effective when you have high pH in the soil, because it precipitates in the soil, so phosphonate becomes not available to the roots as phosphonate. So it cannot act as phosphonate when you have high pH in the soil. Phytophthora cinnamoni is not really a problem in Israel, because Phytophthora is not developing so well also in soils that have high pH. So we have another problem here in Israel, that is Butyrosphaera, that causes dieback symptoms, like in Phytophthora, like the symptoms of Phytophthora cinnamoni. But here the cause is Butyrosphaera. Is not. It's a picture here from Israel, and those diebacks of the branches are symptoms of attack of Butyrosphaera. Now, when you're feeding the tree with ammonium and nitrification inhibitor together, and a third element, also K-phosphonate, what we expect to happen, we expect that is going to be an acidification of the rhizosphere, and we expect that phosphonate will be assimilated by the tree as phosphonate, so it can act as phosphonate, and it can increase the resistance of the tree to Butyrosphaera. We expect also that microelements will be assimilated more effectively by the tree. So with this all together, we can expect an increase in the yield. We can expect Butyrosphaera resistance. We can expect an increase in fertilizer effectiveness, because no more nitrate are going to be emitted to the atmosphere, and also no leaching of nitrate to the groundwater. To test that, we made a research in avocado, in an avocado plot that was planted in 2014. The soil, it's basic, pH 8, 8.2, and a very good parcel, because in the third year, before we did our trial, in the third year after plantation, we got a mean yield of 10 tons per hectare, and it was uniform in all the parcel of the trial. In this trial, we had 4 treatments. The first treatment was fertigated with NPK with the proportion of 5:1:5, where the nitrogen, most of the nitrogen was ammonium. The other 3 treatments received the same basic fertigation program, but we add some other components. For example, in the first treatment, the second treatment, the control, the second treatment here, we combined the basic fertigation with K-phosphonate using a commercial product that is called KIP. The third treatment, we also have had the same fertigation program, but we add the nitrification inhibitor with a commercial product that is called green. And the last treatment, we use the same basic fertigation program, but we add KIP and green together. All those additions were added with the fertigation all the time, with irrigation. Every time we irrigate, all the components was in the water in a constant concentration. Now, you can see here the result of soil tests and the concentration of nitrate and ammonium in the shallow part of the soil and the deeper part of the soil. So you can see the concentrations of nitrate are very low. Those soil tests were done in the middle of the summer, very hot in Israel. Now, when you see here the concentrations of ammonium in the shallow part of the soil, you can see the 2 treatments here with very high amounts of ammonium. Those treatments, the 2 of them receive green. That those treatments are green. The green is the nitrification inhibitor. So as expected, the concentration of ammonium in the soil in the treatments that receive nitrification inhibitor are very high in comparison to control. Now, you can see now the soluble phosphate. The 2 treatments that receive KIP, that is K-phosphonate, it's the blue one and the black one. They have 4 times more, about 4 times more phosphate soluble in the soil solution, in the shallow part of the soil and the deeper part of the soil. So we have more available phosphate to the roots, and we have more available potassium to the roots, also with the treatment that receive KIP with K-phosphonate. This treatment, the blue one with KIP alone, or the black one with the KIP and green together. This is in the shallow part of the soil. In the deeper part of the soil, there is difference, a little difference, not so significant. Now, here we can see the yield of 3 consecutive seasons, 2018, 2019, and 2020. Let's see the results of the first year, the total yield. If you see, you can see here the white one is the control, only fertigation without any addition. When we had to the fertigation KIP or green, we had a significant addition in yield. But the combined treatment, you have an addition of yield of 5 tons per hectare. It's a lot. It's a lot, a very, very big addition. In the following year, in 2019, we had an addition in the combined treatment of 6 tons per hectare. 6 tons per hectare in relation to control. And in the third year after we started the trial, we got an addition of 4 tons per hectare. So if you take the mean addition of the combined treatment of green and keep, we had an addition of 5 tons per hectare, is the mean of three consecutive years. Now, when we started this trial, we had no signs of Butyrosphaera in the field. During 2018, no signs. 2019, no signs. But in 2020, we suddenly got a lot of signs of Butyrosphaera. So we checked that. We checked that according to the treatments. And we distributed the trees in 2 categories. One category is mild signs of Butyrosphaera, is maximum 1 branch with dieback. And more acute, the category of more acute Butyrosphaera symptoms is trees that show 2, 3, 4 branches with dieback. You can see here, when you administrate KIP, only KIP, that is the K-phosphonate, you have some effectiveness in relation to control. So you have a decrease in the percentage of the trees that is in acute category. But look what happens when you are administrating the 2 components together. You get a deep decrease in the percentage of trees that has acute symptoms of Butyrosphaera. The conclusion here is that very effectively, when you administrate KIP and green together with ammonium as the main source of nitrate, of nitrogen, you get trees more resistant to Butyrosphaera. So if we get some conclusions here, we had a very high crop level in the experimental section during 4 years, 2017, 18, 19, and 20. KIP and green, or separately, they cause a significant increase in yield. But when we administrate them together, there is a very much substantial and sharp increase in the yield. So, and this treatment, KIP and green together, we got trees more resistant to Butyrosphaera. It's a very important finding. We have some more time now. This treatment was tested also in another plantation in Sikkim, in the south part of the country, and we also find there that the trees that they had many symptoms of dieback by Butyrosphaera. The treatment helped the trees and sharply decreased the contamination of Butyrosphaera by the trees. So it's not only from the findings are not only from this trial. We had some information of other parts of the country. I want to thank you very much for your attention and make some acknowledgements, because many people cooperated with me to do this trial. The staff from Kibbutz Nachshonim is the place where the plantation, avocado plantation, and they cooperate with me all the time. Gershon Kalian and Liraz Shirshi from ICL Fertilizers, and Mercer Plus Irrigation Company, Sham, the Israeli Extension Services, where I worked for many years, and the Israeli Avocado Growers Board that cooperated me, funding, also giving funds for the performance of this research. Thank you very much again. Thank you very much.